So, as Jay introduced, I'm with IPRD, and we received funding from the Gates Foundation to deploy a number of novel technologies in South Africa. They include a medical wallet and a biometric system. These are both really important technologies to help people access medicine, and access medicine in a way that we take for granted here today. We did deploy a medical wallet program which is really based on blockchain, and we could not have done that without Factum. So thank you guys for having us here today. So we're going to talk about a couple, we've broken this into 6 topics, 5 are real. So really, we're going to talk about identity in the developing world, and really throughout the presentation, we're going to talk about patient tracking. You can't track a patient unless they have an identity, and they might use different names. They might have a lot of different confusing names. It's important that we understand what identity is. It's important that patients have portable medical records, and we'll talk a little bit about that. In South Africa and other neighboring countries in the whole continent, really, decentralization is absolutely critical. And then we'll talk more concretely about the biometrics program we did and the medical wallet program. And then number 6, biometrics on the blockchain. That's the future. That's where this is heading. And that is going to be really where we open it up to have a little bit more of a conversation about how all of these programs can come together. So really, we have identified, and the Gates Foundation has certainly helped us with this, that identifying a patient and the ability to record their record, to give them a permanent record and a permanent ID, the ability to track them and to maintain their record over time and across time, is the way to give them access to healthcare. And this gives them an ability to take control of their treatment and an ability to really access a level of care that does not exist for many people in South Africa, in other African nations, in many public health systems around the world. And really what we're doing is we're following the example of Aadhaar. Aadhaar is India's national identity program. Aadhaar was built to give banking to the unbanked, to give identity to people without any identity at all. And it really allows people that could not even get a cell phone before to get a cell phone, and then all of a sudden they can get a work, or they can collect government subsidies. So we're going to get a little bit more into Aadhaar later, but we talk about Aadhaar because they are the gold standard for what we're trying to do. So just getting a little bit more into public health care, we see patient tracking as absolutely critical. If you look at TB patients, they need to be tracked across time. If you give a TB patient an antibiotic and you don't test them weeks later to see if that antibiotic is working, they're going to develop resistance, and they're going to have antibiotic-resistant TB in their community. So tracking is really critical, even if they go to different clinics over time. In terms of HIV, we see so many HIV patients in South Africa come to a clinic, get a test, and then 6 weeks later when they go to a different clinic, they don't have that test information. So they start the testing process all over again. They never receive treatment, or their treatment is delayed. We need to accelerate their access to treatment. And the really important thing to consider in these systems is that these are public systems. You have these clinics are obligated to treat the patient, whether they have a health insurance card, whether they have a government ID card, whether they have no ID or consistent name at all. They need treatment. So how do we track these people? How do we consistently identify them and give them data-based therapies? Biometrics is really the only solution. And then getting a little bit more into medical records, we see that medical records are super fragmented in these Gavi nations. They are fragmented across different clinics, and it's really impossible to piece all of the data together in order to use the data to support treatment. We understand that patients are able to receive better care if they are able to aggregate their own record, and if they have access to see the data themselves and to see, this is my result from this test, I need to act, I need to take this drug, I need to make this appointment. I need to go back to the doctor and get a new treatment because I see that this isn't working. It empowers patients to access and to act in healthcare seeking ways, and that's something that we have yet to see in the Gavi nations, and we're trying so hard to introduce. And then I think a really critical concept for what we're talking about today, and I think at a blockchain conference, you guys will all agree that decentralization is key, especially somewhere like South Africa. And when I say decentralization, I'm not talking specifically about federation or blockchain or about any one technology, but just the fact that we cannot store all the data in one place. These are really difficult geographies, and communications could be cut from it because of technology. A government could shut down a server, and then all of a sudden people don't have access to a given record. And people just don't trust any one organization to hold their record. So we can really only solve that through decentralization so that people have access to their healthcare no matter what the governments, large organizations, individuals do. That record is pervasive. We also, just through our studies, understand that just a lot more bang for your buck to do lots of little databases or build resources at every clinic instead of trying to build a connected ecosystem of cloud servers and data farms across somewhere like South Africa. So it really is just, from an economic standpoint, it's impossible to try to build large centralized databases and keep them online all the time. And we talk a lot about biometrics. The important thing also to note is that biometrics are not a silver bullet. They don't always help. Sometimes they just add noise. So we need to make sure that biometrics are added in a really thoughtful manner. Because of that, we use two different biometrics. We use iris and we use fingerprint. We capture enough data that even if there's an outlier, someone may be missing a finger, someone may not be able to authenticate one eye, but we want to make sure that everyone is included in the system. And we've managed to implement biometrics in a way that allow everyone to be used without a lot of specialization. We don't need highly trained biometrics operators at every clinic. Doctors, nurses, any other staff can operate the equipment that we've deployed very, very easily. And then privacy concerns are big here. Everyone's concerned about using a biometric. Maybe you feel comfortable knowing that your fingerprint data is stored inside your phone, but you don't want it on Apple's iCloud. Well, people in South Africa feel the exact same way. They know that they don't want their biometric data or a picture of their eye, a picture of their fingerprint. And in reality, it isn't a picture. It's a long string of numbers that's derived from the picture, but we won't get too technical on that today. People don't want that on some national database hundreds of miles away in Johannesburg that could be exploited any number of ways. So we've done a lot of studies. We've been involved with a lot of really broad studies, and we know that people are comfortable with having your data somewhere you've been, somewhere you go. Someone's comfortable having their biometric at a clinic that they go. If they go to 2 clinics, they're comfortable with their biometrics being at 2 clinics. If they go to 3 clinics, they're comfortable with that, but they don't want it in the cloud. They don't want it at every clinic, especially clinics they will never go to. And when we're talking about biometrics, we can't help but talk about Aadhaar. It's the world's largest biometric program. At this point, they've enrolled more than 1.2 billion Indian residents, and they're doing something a little bit different. They capture a ton of biometric data. They take 10 fingerprints, they take 2 iris images and a face image, and they use that to make sure that you are absolutely the only possible person who you say you are. And once they've completed the deduplication process, they issue a number. And you can actually get a lot with that number, even without a biometric verification. You can use that number to get a SIM card for people who didn't have enough identity to get SIM cards, to open a bank account, to get social services. And Aadhaar really has been built to use a technology to make inclusion possible. And there has never been a biometric program this big, so they are absolutely the gold standard. So we built a biometric program in South Africa, and we took a lot of cues from Aadhaar, but we also did things differently. India has a lot of resources, and India has a lot of central coordination, and that just doesn't exist in South Africa. And we're not trying to get governments to run this. We're trying to get something that is really much more sustainable. So they did one huge issuance. They built this program across the country in one fell swoop. We're doing something decentralized, and because it's decentralized, we use a poly-unique ID. That's a concept that we'll talk about a little bit later in this presentation. In terms of the deployment, they did one huge deployment. They had billions of dollars, rupees probably, and they implemented a gigantic database, and they brought in companies like Accenture and Morpho to run this project. We didn't do this. We can set our technology up in one clinic, and when another clinic wants to join, we can add that clinic. We can also take that clinic out. So if a company doesn't want to participate, we can easily take them out of the system. That really lowers the bar for their decision to participate, as long as they know they can exit easily. And then in terms of identification, as I said, Aadhaar uses a number. You may have to present your Aadhaar number or know your Aadhaar number. Because someone who walks into a clinic in South Africa needs to be able to receive treatment regardless of whether they know their number, have a card on them. We do biometric authentication every time someone comes in. And even if they don't have a card, we identify them by their eyes, their fingerprints, and we treat them. And then in terms of this being a single database, Aadhaar is one single gigantic database. What we do, we have a lot of local databases, and we link them in a way that looks to the patient, looks to the clinic like one single database. It gives the patient all the benefits of having their data on one single database without having to have that big infrastructure. So I talked a little bit about poly-unique ID before. We know that a non-unique ID, two people match with the same index number. An ordinary unique ID, one person has one number, another person has another number. That's simple. A poly-unique ID means that one person may have multiple index numbers, and I may have two index numbers, Jay, you may have three index numbers. As long as none of these numbers overlap, they are still considered unique. They are poly-unique, and they can function as a single index number as long as we build tables that tie them together. And that means that at clinic A, B, and C, where I go, I may have three different IDs. We don't have to change the numbering system, change the infrastructure at all of these clinics. We just create a federated table that links them all together. And that's a lot easier in South Africa than starting from scratch and building huge new piece of technology. So how does this work? In our decentralized approach, a patient walks in, they get enrolled, that is where their data resides. If they go to another clinic, their data gets pulled into that. We scale as patients go from one clinic to the next and as clinics join. But we don't rely on any outside programs. We don't rely on national IDs or any other identifiers. So a patient walks in, we capture 10 fingers, we capture 2 irises, and we deduplicate them. And then we print out a sticker or a card, and that patient, it's a scannable card, they can take it throughout the clinic that day. They take it to the doctor, they take it to the phlebotomy station, and everywhere along the way that's scanned, that every single treatment, every single test gets appended to their record. And if 2 clinics decide to participate, there's no central database. They simply share the tables or share their use tables linking the 2 records, and we don't see a cloud. This is not a cloud. This is just an internet connection between the 2. And we're able to identify people with their biometric across the 2 clinics. And what we see is that even with these 2 tied together local databases using the federated biometric technology, we have 2 different populations of patients. We have populations that are on the outside that are absolutely unique to each clinic, and then we have populations that are shared across clinic. And those 2 people on the inside, those are the ones that are getting the most value. They can get a test at one clinic and the next week pull up their results and get treatment at a different clinic instead of starting the process all over again. And then really a complementary program we did was the medical wallet. And we see that typically a medical wallet or a EHR system is owned by a clinic, owned by a hospital, owned by a healthcare system. And it really comprises their records. The solution that we delivered for South Africa, the wallet is owned by the patient. The patient owns their data, and every time they go to a new clinic, that record gets appended to it. So they aggregate or accumulate a more comprehensive record with every clinic they visit, with every doctor they go to, with every hospital they visit. And we knew that this had to be decentralized. Even here we talk about trying to do decentralized technology. That just means that we use lots of complex databases that we try to tie together. It doesn't work. It's complicated and it's really difficult to maintain. It's expensive. And obviously that's not what we're looking for in South Africa. So we implemented blockchain. And the blockchain approach means that all the records are guaranteed to be identical at every node. There's an immutable ledger. There's an audit trail. And the protocol is self-maintaining. There's no personnel required to manage database. And it's really hard in South Africa to get a team to manage a database of thousands or millions of medical records. So we took a cue from Apple's medical wallet, Apple's health app, and we wanted to give patients, like Apple does, access to their data. But we couldn't store it in the cloud. That's one thing Apple does. And really, no one trusts the cloud. No one has a way to secure the cloud, and there aren't a lot of clouds in the remote villages in South Africa that we're serving. And there aren't a lot of phones that run apps. And while it's important that patients are able to share information from their wallet to another doctor or grant another doctor permission to their record, patients there are less concerned about the sleep app or the mindfulness app. So we built a South African version. We give them access to their records. We make sure that they're able to designate their record to a new doctor, nurse, or clinic. But this is accessible via a micro web service or text-based. This works on a feature phone. And when 10 people in a household are sharing a phone, we make sure that their privacy is absolutely guaranteed and that no one else in their family or in their household is going to look on that phone and see their medical record. So why did we use blockchain? We have a lot of issues that are specific to South Africa. Maybe they're not specific to South Africa. Maybe these are really global issues. People don't want to trust a single entity with their data. They don't want to trust a government or a corporation. These databases have to be resilient. They have to be resilient from a technological standpoint, an infrastructure standpoint, a political standpoint. And we need to give value to the data in the wallet. If a patient walks into a clinic with a piece of paper that says, this is my results from a test, doctors aren't going to believe it. They're going to run the tests all over again. So we looked at blockchain as a way to solve that problem. So what we're able to do, we took 2 different approaches. You could store all the data on the blockchain. It's all trustless, on a trustless immutable ledger. And we built additional features that could handle the scalability, security, and privacy. The alternative is that we stored a hash of all the data on the blockchain. And the hash is able to provide a certificate of the heritage of the data. And that means that it generates a shield on the data. And when the patient looks at that shield, or when they present it to a doctor, it says this data comes from X clinic. This data has been verified by the blockchain. This data is real. And that is one of the things that we're doing to help make patients comfortable with the data that they're looking at, but also help build trust between the patients and the doctors. So feedback. We ran this program in South Africa, and we expect people to be apprehensive when introducing technology. This is not necessarily a group that is very comfortable with technology, and we see that people still perceive the technology to, even with the big picture risks, they understand that it's secure. They understand that it's helping them get the treatment they need, and they really appreciate what it does to them, for them, and they appreciate that they can see the security. It's presented in a very visible manner. The shield that comes up helps them understand how their data is encrypted and tied to the full data in the provenance that's visible to them. They consider the ability to send and grant another doctor or clinic with permission to see their records. They consider that to be critical, so that they don't always have to go to the same doctor, or when they go to a new doctor, they can pull up that record and understand that patient's history, and they're not starting from zero every time they go to a clinic. And they like that it has the possibility of reducing wait times at clinics. They can really triage patients from their home, bringing in the patients that need treatment most, and keeping the patients at home supported when they don't need to come in immediately. There's also a lot of ways that patients can access support and counseling information while they're waiting for test results. And finally, the patients really like that we built something that worked on their phones and worked in their language. Not a lot of people come in to South Africa and build technologies that work in all of the different languages they use and all of the different phones they use. They don't all have iPhones or Android phones. None of them do. So what's next? This is really opening this conversation up to more of a Q&A. We think the next thing, obviously, these two programs that I talked about were discrete programs. They're going to converge. Identity is as important as storing medical data, and we want to store that biometric on the blockchain. We know that when you enroll a biometric, you're only doing one single write to the blockchain, and we think that that's really optimized for the blockchain's throughput. We see the convergence of the medical wallet and the decentralized biometric ID creating a platform, and we can layer other technologies on top of that platform, automated, machine-guided diagnostics, and all sorts of other things that can support doctors and support patients. So this is really giving a patient a record and giving a patient an ID are really just the beginning of the technologies we can introduce. Right now, we're using a private blockchain. We're hosting it on nodes in South Africa, but we see opportunities to do a public blockchain as well. This is early stages in this program, and there's a lot of opportunity for this to evolve. Jay, if there's anything more you want to add on how the blockchain works in this?
I believe you guys are doing Factum with Factum, though. You're using public blockchain, or private blockchain, but you're actually writing proofs out to public blockchain so that you can go to another private.
Exactly.
So to follow up on that, you talked about how Apple Wallet, people don't want to trust that, or Apple Cloud, and how they don't want to trust the various corporations. If you have a private implementation. Testing this, okay. So you talked about how with Apple Cloud, people don't trust that, or people don't trust corporations. With a private blockchain implementation, aren't you asking them to trust whoever the node providers are?
Yes. But I think that the way the data is handled on the blockchain, and the way it is not just stored in one single node, but the way it is stored across many nodes, people don't have to trust any single provider, and there becomes a certain anonymization of that data.
So you alone don't control the nodes, you have different companies controlling the nodes?
We control the nodes at this early stage of the program. As this program grows, we certainly have no intention of controlling the nodes or owning that patient data. We do want this data to be democratized.
Great. Thank you, and best of luck with this.
Thank you.
So if the South African government wanted to make this their national system, it seems like it could be scalable. And I mean, but would patients really go into a hospital and say, I'm worried about my information, so don't treat me? I mean, is that a concern?
If they wanted to make it their national system, and right now we're absolutely operating in parallel to the government of South Africa. We are not, this is a program that is, supporting a part of the population that is a tier below that the government of South Africa is really treating right now. But I think we would have to go through a number of steps to educate patients and help them understand, yes, this is part of the national health program. Are we storing all of your data in a single place? As the government of South Africa, are we building one giant data repository? And that would absolutely have to be no. And that we would have to find an architecture and a system that and an educational program that helps patients understand that even though the government of South Africa was supporting this program, they were not just hoarding everyone's data, because that's not a system that people, except in India, are really going to be comfortable with.
Yeah. I am struggling with a use case, so just bear with me here. You mentioned the India model. So for me, my understanding is that the India model is completely centralized. It's not blockchain, and if it is, it's not. It's very centralized from cradle to grave. And
Absolutely.
And I don't know if I would refer to that as the gold standard from a, philosophical perspective.
From a scale standpoint only. It's amazing what they've
even
done. It might not be everyone's ideal. I understand that.
Yeah, no, and I'm not arguing. I mean, and which, by the way, might be great for India because that's the only way they're going to get people, as you said, better services. But they could turn off individual's ID at any time without any problem, and that's just the way it is. So that said, as I'm just kind of reflecting to the parallel that you had on that slide there, I would not definitely go down that path. But that said, the use case that you're presenting here, and I'm kind of new to this game, but I hear distributed and I hear decentralized. And most of your side, I'm kind of wondering to what extent this could be solved by having an IBM get in there and put up a couple of, distributed databases across these clinics with a little bit of good encryption and a wallet. And in other words, is this really decentralized? Is this really a blockchain-based environment where consensus is, trustless, blah, blah, blah? Or are we, I'm confused about the use case and the decentralization.
Sure. So absolutely. We're really talking about right now there are two discrete programs. And it's really for us, for our partnership with Factum, and for the Gates Foundation, as well as the participants in South Africa, determine how these programs come together. But we talk about the medical wallet program. That is absolutely blockchain-based. We're also talking about a biometrics program, and there is no blockchain component right now to the biometrics program. I think the best word that we can use to describe the biometrics program is federated, and that means that every single clinic is operating its own system. And every patient is comfortable knowing that when they go into that clinic, if they're providing a biometric, they're providing it to a computer in that clinic in a highly encrypted manner, but it's not going to the cloud, it's not going to a clinic next door or 100 towns over. And we're tying those clinics together using a federated system. So I'm not really sure if decentralized absolutely reflects what they're doing. But these are local databases, and they're federated in a way that everyone has access. Any more questions?
So I used to work at IBM, and I was involved in Watson and blockchain and analytics. So how would you compete if IBM said, you know what, we're gonna put a bunch of nodes and a bunch of servers on in Africa, and it will always be private because that's how IBM works. They're very data security intensive. And of course, when you're dealing with HIPAA laws and everything like that, yes, of course, they might not apply to Africa. I was, how do you match up to a multi-billion-dollar company that has all these resources and 400,000 employees?
We don't want to compete with IBM. If they were going to come into South Africa and operate a program that gave everyone there a medical record and gave everyone there an identity, we would be thrilled. We would help them. So we would actually, we've put a lot of our developments on open source, and we hope that IBM could incorporate that as they go in there with millions of dollars to build this infrastructure, and they could use a lot of our ability to operate networks across really difficult environments. But we're not trying to compete with them.
Okay, so are you starting to approach companies that would be very interested in putting capital into their developer resources to help contribute to this open source technology? Is that one of your big moves in terms of growing the actual code, the actual platform?
We're building this out further. We're going to continue to evolve it, but in the very near future, we will absolutely build programs that encourage other people to take this out to the field. We don't want to be the only ones that can do this or take any ownership of this. If this is a technology that can help tie clinics together in rural areas, we think anyone should be able to do it. I can hear you. It's a small room.
This way it gets the answer, the questions get recorded.
Right.
So which blockchain does it use, in fact? Is it based on is it Factum's blockchain, or is it a different one? And are there any tokens involved in it, or is it a tokenless environment?
If you could hand your mic up 2 seats.
Yes, it uses the Factum blockchain. The Factum blockchain is a 2-token system, and so there aren't any tokens in like a Bitcoin token involved in what they do. In fact, they really don't have to deal with tokens at all because we were designed for data, to solve problems with data rather than to solve problems of passing tokens around. And so we have a token, but it's completely segregated again away from the use cases where you'd use it in in a medical setting or in a banking setting, because in either case they're not going to want to deal. I mean, doing a coin transaction is not the use case they're doing, and so we don't force them to try to fit their use case into a coin transaction, if that makes sense.
Right now, we're validating data, and the blockchain is awesome to help us do that. At some point in time, if we need to build an incentive system to help more clinics, more patients participate, certainly possible that a coin or a token of some sort might be really important to help, but that's not where our project is right now. Exactly.
So even with if it's a private instance at present, or you go hybrid where it's Factum on Factum like Jay talked about, or you go public, do I understand correctly that while the 2-token system removes companies like his from having to hold the token, they tap into a subscription model where they pay some monthly or daily amount to enter data into the blockchain, but it still uses that underlying Factum cryptocurrency? It uses entry credits. So the Factum protocols, factoids, are being utilized to create those entry credits, and then those entry credits are being utilized to put their data on the blockchain. They, just as a company, don't have to worry about it because it's done by a subscription model behind the scenes. Is that what's going on here? So the ultimate implementation will be that model. Great, thank you.
Anyone? Thank you.